This is an article I posted on my LinkedIn talking about the convergence across world models, conscious machines, and the general architecture of intelligence. Here we go. We're watching three parallel streams of AI research converge on the same insight, where intelligence is more than just processing symbols. It's about building internal models of reality and trying to use them to navigate the world. The way that I've come about this is from a background in biomechanics, where I learned a lot about the body, and then now human factors, where I've learned a lot about the brain, cognitive protocols, and behavioral sciences. So let's first talk about Ian LeCun. He formerly worked at Meta, and he's now building world models that learn about physics from videos. We also have Dr. Fei-Fei Li, who's building spatial intelligence for robots. The next big name that we have is Richard Sutton, where he talks about the idea that experience is the substrate of intelligence. It's not just this predictive model. There's this sensation, action, reward loop that's continuously happening. And underneath all of it, this is the thing that I'm most interested in, we have Manuel and Lenore Blum, who have given us the theoretical architecture for what computation or how consciousness presents in a computational system. I wrote what consciousness actually does in a computational system. What's emerging is not about the focus on better artificial intelligence, but rather understanding how intelligence operates. So the Blums specifically talk about the idea of conscious Turing machines. We'll dive deeper into that. So let's start with the Blum's specific Turing machine. So we have the three interacting information streams that are happening. We have this up-tree competition, which I think of as the bottom-up sensory processing. There's raw sensory data that's competing for attention, flooding upwards from the perceptual periphery. Then we have this down-tree broadcast, right? The body has received these up-tree competitive signals that are fighting for attention, for grouping, and now we have this down-tree broadcast, which is the top-down cognitive processing. The winning chunks from the competition that happened are the ones that are getting broadcast back down with a new command based on the input that we have, which shapes what gets attended to next. So in this case, the sensation is shaping thought. And critically, there's an element of working memory where these streams are meeting. It's sort of this like limited capacity buffer that's holding the attention. Think of like RAM or cookies or session history. So this is about a computational model of attention-driven awareness that has what we call specific information flow dynamics, because we're thinking about information processing systems and then the dynamics of how that information is relating to each other, right? So this is information flow dynamics. So the up tree, the competition, is what's bringing the world in, and the down tree is what's applying that learned structure back into the body to then express. So we have sense, then we have the think, and then we act, which is the expression of that. So the Blums are showing about this architecture of this specific pattern of competition, broadcast, and integration is what's creating something that might be functionally different from like the ELIZA effect or a Turing machine by itself, where we're not thinking about can machines think, but what does it mean to try to understand consciousness in this modeled format. So this is a system that holds this internal model, updates it based on sensory evidence, and then uses that model to guide specific action. So now let's get into the biology. So human factors and biomechanics have talked about the continuous feedback loops that process information. So it's a non-linear processing format. So the sense, think, act loop is foundational. You sense the environment through multiple modalities. You have vision, proprioception, vestibular input, and tactile feedback. You can then integrate that into a coherent world model through cerebral and cortical processing. There's another concept called criticality where we talk about the cortical conductor. I would love to talk about that later. I'm going to focus on this now. So we want to sense the consequences of actions from the planned and execution stage of those actions. This is how we update the model, right? We understand what is the planning, the execution, and then we try to predict what are the consequences in order to understand how this loop can be affected, right? How do we iterate on this loop? So this is where the brain-body feedback loop adds another layer, because your body's configuration constrains what you're able to perceive. It gives you a certain set of affordances that you have. Your perceptions shape what actions are available, and then your actions change your body's state, which changes how you're going to perceive the next thing, right? Because you're in a different state of the world. So embodied cognition is a biomechanical reality. It's not just this philosophical approach that we have. We can't separate the sensing system from the motor system or from the cognitive system. It's all this single couples dynamic system where we understand the substructure of all of them, but we still need to understand more about how do they interact coherently to form this one classic system. So this is why traditional AI has struggled with robotics, because we're unable to answer where am I in space, what configuration is my body in, and what forces am I experiencing. We need the motor downtree broadcasting, and it needs to predict these sensory consequences. If I move this joint this way, this is what I should feel. This is what I teach in the physical therapy clinic to people. I want to give them this world model, if this, then that, and build that so good that they're able to apply it in their own lives without having to think about it as much. They're able to intuitively just understand, here's how I functionally move in order to engage with the world the best way that prevents pain and results in pain-free movement. So let's talk about Gibson for a second and this ecological psychology concept of affordances, where the environment offers these possibilities for action, but only relative to your embodied capabilities. You have a configuration, the world has a configuration. How those gears meet and mesh is exactly what that affordance actually is, in my opinion. So the conscious Turing machine's working memory, to me, is the representation of this, where it's what can I do right now given what I sense and what does my body make possible. So here's the kicker. When we design interfaces, physical tools, or training systems, we're already working within these loops. We optimize for the human sense, think, act cycle, and we account for the proprioceptive feedback, visual motor integration, and we add for cognitive load and working memory, right? We think about load management not just from a cognitive perspective, but also from a physical body perspective. So what's happening now is that we're building these artificial systems with the same functional structure. It's biomimicry happening, but at a much larger scale because we're approaching this intelligence and this kind of mind. So now let's talk about LeCun's world model onto this architecture. We have joint embedding predictive architecture, which is what LeCun's world model talks about. I like the joint embedded part because it makes me think about bones and fascia, which I have 2 other videos on my channel. If you want to check those out, check those out. So this is about where VJPA, visual dynamics, or visual predictive models, where it shows you video and it tries to abstract away these intuitive physics, right? When you try to catch a ball, you just know how to do it naturally. You're not thinking, here's how fast the ball is going, here's the angle at which it's coming from. You're not doing physics equations in your head. You're just grabbing the ball and catching it. Or maybe you're not. So when you have a world model, you're taking in that passive reception of sensory data, but then actively trying to interpret it well and make some of it an active reception of sensory data, because we're generating predictions about what should be there, and the uptree competition is the computing prediction error, where you're going through that pre-attentive processing that's coming up from that sensory system before cognition is hit. So that pre-attentive grouping had better be good, because if that equation is also mismodeled, then you don't have a good grasp of this intuitive physics that you're trying to do, because the grouping that's happening prior to cognition is already maybe misinformed or not as coherent as it could be. Then we have this world model downtree, where it brings the learned physics, the learned structure, and the learned priors about how the world is operating. Where now working memory is where prediction is meeting reality. Now LeCun's systems learn this structure through self-supervision, where there aren't rewards or labels, but there's just the statistical regularities and considering what are the outliers. So we're not going through this reinforced learning kind of process, we're going through more of this open-ended learning process. I really like this when I think about world models, because I think about the human body in terms of like orientations and relative motion, right? You have a certain orientation, that's your world model. We're gonna get here into a second about how spatial intelligence comes into play and the intuitive physics to talk about the relative motion in between those orientations, right? You can perform the same squat movement but still try to facilitate different kinds of relative motions in between. So now let's talk about Dr. Feifei's spatial intelligence. So Marble is their world model platform, where it lets them create and reason within simulated 3D environments. So this is about spatial prediction, where we try to understand what are the physical consequences of the actual actions that we might end up taking. So this accounts for geometry, gravity, collision dynamics, inertia, momentum, etc. So for a conscious Turing machine, this solves the grounding problem that we have. The uptree is more than just this abstract sensory features. It's about these located sensory features that are localized in these specific places. That's what I mean by located. Proprioception, spatial position, and object relationships in 3D are now presented in the format of, here's what might happen from this position if I move this way. That's the inner proprioception that the Blooms talk about in terms of these special equations or algorithms that are operating within their particular model, where the system models itself within the world with a body schema, an egocentric kind of frame of reference, and a sense of where it is and what it can do. And this spatial intelligence is what we need for humanoid robots, which is where all of this is now getting tested and showing up. So now let's talk about Sutton just a little bit, where I want to think about this idea of this continuous process that's happening, where we go through sensing, predicting, comparing, updating. I've had a previous video where I've talked about the loop of sort of perception, interaction, propulsion, locomotion. Now I just call it perception, intention, expression, or sense, think, act. These are different models, right? But we're just thinking about how are these integrated models being presented, and I think it differs a lot from LLMs, where that just focuses on the verbiage and maybe the actual command module, where that's the downtree broadcast, but I don't think it does a great job of interpreting that sensory information, because that's already the language model post-integration of the sensory processing, where now we need a different way to understand how to navigate that sensory processing itself without language, right? This is why people talk about those meditative exercises of try to watch this and pay attention, but then don't use words to describe it, and now all of a sudden you have this great greater appreciation for what's really going on. So now I want to talk a little bit more about the integrated architecture, but I think I'm losing time. The total thing that I'm trying to bring together here is we have this theoretical model of consciousness, world models, intuitive physics, and I think these insights are really reflective of what I've seen working with the human body, so I'm excited to see how they come together to understand humans.